Hello everyone, we have developed our project in 2 phases and already completed our first phase. In our first phase, we have developed 3D models, navigation simulations, mapping simulations. Now, moving to the 3D model, as you can see in this model, a screen is attached at the top for one-on-one interaction with people, and there is a plate attached for delivering medical supplies along with the bin for waste collection and sanitization. And at the peripheral of the body, there are UV lights for disinfection. Now, coming to the bottom of the model, there is a LIDAR sensor mounted, and beneath that, all the electronic components along with motors and batteries are placed. As you can see, we are running a ROS launch command in the terminal to open both Gazebo and RVIS, which provide the simulation environment for this project. We are using an online asynchronous mapping algorithm for the SLAM2 toolbox to map the environment. In the top right corner, you can see the Gazebo window where we have set up a 3D simulation of the hospital environment with robot moving through it. On the bottom right, there is a terminal window where we control the robot's actions. The robot is navigating through the surroundings to generate a map using a LIDAR sensor. LIDAR helps the robot measure distances to objects around it by emitting blue light, which you can see in the Gazebo simulation. As the robot moves, it collects data from both the LIDAR sensor and the motor encoders. This data is fed into the SLAM algorithm, which helps the robot build an accurate map of its environment. The algorithm creates a map of the area and also helps the robot figure out where it is in that space. As it progresses through the hospital, the robot dynamically updates the map, noting the structure of the hallway, the layout of rooms, and the positions of the obstacles, such as furniture or equipments. Every time the robot encounters a new area, it adds that space to the map. Now, the navigation phase will begin. The robot will use the map it generated during the mapping phase to autonomously navigate the hospital environment. We have initiated this process by running the navigation launch command, which activates the nav2 packages for localization and navigation. The localization package will provide real-time positioning similar to GPS, while the navigation package will handle path planning and obstacle avoidance. On the left side of the screen, you can see the RVIS window displaying the layout of the map created by the robot. Within this window, a green arrow indicates the desired destination set to the reception area. The robot uses this map to plan its route, skillfully navigating through the environment while avoiding obstacles. Next, we are commanding the robot to move through the hallway. To test its capabilities, we are introducing some obstacles in its path. This will allow us to evaluate how well the robot can detect two new objects using its LIDAR sensor. As the robot encounters these obstacles, it interprets the real-time data and adjusts its route accordingly.